In this problem where we have we can see in the diagram a right triangle, so it's easy that we can use the Pythagorean theorem to find any part of this triangle. Depends on what they ask me to find, but the relationship of the sides of the triangle, if it's a right triangle, it will be this, where we have the longest side of the triangle, which called the hypotenuse. When it's squared, the hypotenuse squared, it equals to the square of the squared of the sum of the squared of the sides of the right triangle, the right angle. So this is the right angle, and then the sides of the right angle, when you square them and then add, you square them and then add, it equals the square of the side that is the longest, also called the hypotenuse of the triangle. So that's what we're going to use here. So let's read the problem to make sure that we understand what they say in the problem. So in this problem, an electrician needs to run a cable from the top of the 52-foot tower to a transmitter box located 39 feet away from the base of the tower. So two informations had been given here. First, it's a 42-foot tower, means that's the tower, the top of the tower, where we're gonna come from to have the cable to the ground, is 52 feet, and then 39 feet away from the base is the horizontal distance on the ground where the box will be placed. And then we also see that we need to find the length of the cable. That means how long should the cable be? So we know what A is. A equals 52. A equals 52. A equals 39 feet. And then B equals 52 feet. Another representation of this formula is, since I want C, I can take the square root of both sides to isolate the C. Or if in this equation I wanted to solve for A, for example, I will keep A where is it, subtract the B squared on both sides, and then take the square root of both sides of the equation to find the A. So since C squared is already isolated, now if I want C by itself, I can just take the square root of both sides of my equation, and since it's a distance, it's automatically going to be a positive number, so I don't even have to consider plus or minus. This is not needed because it's going to be a distance, so it'll be automatically a positive value. So I'm gonna have C squared, C, because I took the square root, equals the square root of 39 squared plus the B value 52 squared, which is equal to the square root of 4,225 when you do it. And then the square root of 4,225 equals equals 65 feet. It's important that you put the unit. So the length of the cable equals equals 52 feet under 55 feet under these conditions. Remember, it's important to put the unit. If you don't put the unit, the credit is not full. Also show your work, then and you get full credit. The next question is to solve the equation. To solve the equation, square root of the square root of 9x minus 5 minus 7 equals 0. So we know that we're solving a radical equation because we see clearly that we have the radical. Step one is to isolate the radical. So in this case, to isolate the radical, we need to add 7 on both sides. That cancels this 7 on this side. So we get -7 on this side. And then you have square root of 9x minus 5 equals 7. And then now we want to cancel the radical. It's an index 2 for this radical. So we raise to the power 2 both sides of the equation. And then we got 9x minus 5 equals 49, which is 7 times 7. And then now we can add 5 on both sides. So then we get 9x equals 54. Then we divide by 9. We divide by 9, and then we got x equals 6. So we're not consider this as the solution until we check and verify that this verifies our original equation. Because like I said in class, we don't know when a radical equation will have an extraneous solution. So that's why I'm going to check for extraneous solution. Extraneous solution. So we plug in 6 into the original equation. So that's 9 times 6 minus 5, and then minus 7 is expected to be 0. So if it's not 0, then 6 is not a solution. If it is 0 both sides of the equation, then 6 will be a solution. So that is the square root of 9 times 6 is 54 minus 5 minus 7. So that's square root of 49 minus 7 equals 0. Minus square root of 49 minus 7, we think that should be 0. And then after that, the next step will be to solve the square root of 49. Square root of 49 is 7 minus 7, that's 0. So we have 0. 0 is 0. So that checks my solution. And then I can now present the solution of my equation, that is 6. And we must do that every time we have an index even. We must check for extraneous solution every time we have an even index. So since I said it's when you have an even index, in this case, we do not have an even index, we can solve. The only time you can check is to verify your equation to see if you did good work on your equation. Otherwise, there is no need for you to check for extraneous solution. So in this case, I'm not gonna check for extraneous solution because I know that my index 3 is odd, and I'm gonna be cautious when I'm doing my work, so I will not check. But you can always check for yourself if you want to. I'm going to put pressure on you to verify only when you have an even index, because you don't know when it's going to be a solution will be an extraneous solution. So I subtract 4 on both sides, I add 4 on both sides, and then raise this time to the power 3 because that's the index. And then that cancels the radical. I'm left with x minus 4 equals 64. And then I can add 4 on both sides of my equation. And then that is x equals 68. X equals 68 is the solution of this equation. And there will be no need for me to check for extraneous solution because the index is odd, I'm sorry. Okay, next problem. So same thing, we just have to isolate the radical and then raise to the power equals the index, and then solve for x, and then check for extraneous solution. So -5 here cancel. So square root of 8x plus 5 equals -5. When I see that after I isolate the radical, even index only, I have an equation that has the radicals only on one side, isolated, and then on the other side, I have a negative number, no variables, only a negative number. I am expected to have a no solution equation because the square root or any positive or any even index of a radical would be expected to give me a positive answer. But I'm gonna solve it here. But if you can tell me that with a well-written sentence, you will have the same credit as you did the work and verify. So you can either write a sentence that describe the situation where you have a radical with an even index isolated on one side equals to a negative number. That is always a no solution equation because this is not possible for an index even radical by itself for the result to be negative. But let's solve it together. The index here is even if it's 2, actually. We raise both sides to the power 2. And you see how I take the habit of putting my parentheses around everything? Here, some of you may think that, oh, I can just raise it like this. Nope, it's not right. You should put your parentheses around the entire expression that you want to raise, mostly when you have a negative number or you have terms, more than one terms. If it's just a number without a negative sign, it's okay. But otherwise, even if it's a negative number, even if it's a positive number, you will always see me put the parentheses to make sure I show you that when you raise to a power, what the parentheses shows you what is being raised to the power. In this case, the 8x plus 5 equals 25, not because it's negative raised to the power that is going to be still negative. Raised to the power, whether it's negative or positive, it turns positive. So then I can subtract 5 on both sides, and then I will get this as 8x equals 20. Then I divide by 8 to isolate the x. X equals, simplified by 4 in this case, I have 5 over 2. Then I try to verify. I'm going to verify. I should verify. Okay, and then now I can plug in x equals 5/2. X equals 5/2 in the previous equation, which is the square root of 8 times the x value 5/2 plus 5 plus 5 again on the outside of the radical is expected to be 0. Okay, so I'm going to continue up here. So square root of the square root of 8 times 5/2 is 20. 20 plus 5 and then plus 5 on the outside is expected to be 0. Otherwise, 5/2 is not a solution. So we got the square root of 25 plus 5 equals 0. 25 is square root of 25 is 5. So 5 plus 5 is equals 0. So then it means that 10 equals 0. Nowhere in the world that 10 will be 0. So that explains why this value 5/2 is not the solution. So 5/2 not being the solution, I can make the conclusion that my solution is nothing. So no solution, actually. My solution set is empty. No solution. No solution. Or empty set. No solution or the empty set. So that was it for radical equations. Now let's solve equations using the square root property. When solving the square root property, we need to solve. If I have a squared equals b, your solution will be given by a equals, if you want to isolate b, and then if you want to isolate a, so a would be plus or minus the square root of b. Always plus or minus. Remember that. In this case, we will have, when we take the square root, actually we take the square root of both sides of the equation, but remember to put the plus or minus. Remember to always put your plus and minus, because both solution will work when you're solving by the square root property. So we take the square root of both sides of this equation, but I like to rewrite my expression to create room to put my plus or minus. So x squared equals square root of x squared equals plus or minus the square root of 100. Okay, so square root of something squared, square and square root, they cancel each other. So I'm left with x on this side equals plus or minus The square root of 10 of 100 is 10 because 10 times 10 is 100. So that's 10. So my two solutions are 10 and negative 10. Or if you want to give me just the I don't see why you wouldn't do any of these. So that also can be considered as your solution. So one of them, not both of them. It's one or the other. Next step. We have this equation. So x squared minus x squared plus 20 equals 20. We want to solve it using the square root property, right? So that's the square root of x squared equals plus or minus the square root of 20. And then we simplify the square root, always simplify. So 20 equals 4 times 5. We know what the square root of 20 is, or 4 is. Square root of 5 is not a perfect square, will be inside of the radical, but square root of 4 is 2, and then square root of 5. Then come back here to say that you have x on this side, and then on the other side, plus or minus 2 square root of 5. My two solutions are 2 square root of 5 or negative 2 square root of 5. So we have the two possible numbers that will verify the equation. Two square root of 5 and negative 2 square root of 5. Well, you can do the same over here as well. As long as you have something squared equals something, then you can take the square root of both sides. Always remember the plus or minus, and then solve it for x for your solution. So over here, that's the square root of x minus 5 squared equals plus minus the square root of 12. 12 is 4 times 3. Then the square root of this will be the square root of 4 times the square root of 3. So square root of 12 is 2 square root of 3. So over here, my radical is simplified, and then I can have x minus 5 on this side equals plus minus the 2 square root of 3. So add 5 on both sides, and you have x. I like to, that's not a bad choice, but I always like to separate my equation, right? Since I have a plus and a minus, so I would write my equation as x minus 5 equals negative 2 square root of 3, and then create another equation with the other value, that is x minus 5 equals 2 square root of 5. Now, the reason why I do that, I'm not saying that the other way would not be good, but when you do that, it prevents you from thinking that you just add and subtract the values, because if you add the 5 and subtract, sometimes you forget what you're doing. But if you solve the equation separately, it prevents you from making some mistakes that you would have not made if you did the separate equations. But if you feel comfortable not making mistake with one equation, the plus and minus, go free and do it. But if you don't do it right by doing the separate equation, I would put the blame on you, and then you would not get the credit. I mean, if you make the mistake, either way, you wouldn't get the credit, by the way. All right, so plus 5 on both sides for all the equations, plus 5 on both sides. And then x equals 5 minus 2 square root of 3 for this one, or x equals 5 plus 2 square root of 3. This is a 3. 3. And then your solution set is the first one, comma, the second one with the negative sign, with the positive sign. And then that is your solution set here. All right, so same thing happened for the next problem here. Same thing happened. You will need to take the square root of the first side, 2x minus 7 squared equals plus minus the square root of 18. Think about how you break down the 18 to get one perfect square and another one. So basically that's going to be the square root of 18 equals square root of 9 times square root of 2. So that's 3 square root of 2, right? And then that's 2x minus 7 equals plus minus 3 square root of 2. And then now we separate the equations. 2x minus 7 equals 3 square root of 2, or the other equation will be 2x minus 7 equals negative 3 square root of 2, right? And then we add 7 on both sides. Add 7 for this equation as well. 2x equals 7 plus 3 square root of 2. And then 2x equals 7 minus 3 square root of 2. And then last step would be to divide both sides by 2. And then we get x equals 7 plus 3 square root of 2 over 2. And then the other one is x equals 7 minus 3 square root of 2 over 2. And your solution set, of course, will be the two values of x. The two values of x here. First one, is 7 plus 3 square root of 2 over 2. And the other one is 7 minus 3 square root of 2 over 2. And how about this one here? What do? Well, when you're solving using the square root property, you may see that we always have the square on one side, the square value or expression, the squared expression on one side, and then the other term or value on the other side of the equation. You do the opposite you would do if you were to solve an equation that you want to put in standard form, a quadratic equation you want to put in standard form. So whenever it's a term that is squared and a constant your equation possess, you may want to move one term, the constant, on the other side and take the square root of both sides. Okay, so that's why we subtract 49 on both sides here, and x squared equals negative 49. And then we take the square root of both sides in order to get the solutions, and then plus or minus. But there is a situation here that we need to take care of, because we see a negative sign inside of the square root. We've seen that before when we were doing radicals. We knew that whenever we're solving a radical, right, with a index that is even and then a negative number, we should consider the I property, where I equals the square root of -1. Now we can separate this factor into plus or minus square root of -1 times square root of 49. And then now we are free to say that x equals, this is I, so that's I, and then times the result of the radical in a regular life, square root of 49 is 7. Plus or minus, we will not forget it. You can see me forgetting it, but I will remember at some point anyways. So then x equals two values, 7i, or x equals -7i. We know that these solutions are not real. They are imaginary solutions. But of course, we need to solve anyways, because when it says solve, they want to know whether you have a solution or not. Now, if you don't have a real solution for a quadratic equation, it does not mean you will not have a solution that is complex. If they said, find the real solutions of this equation, then you would say, well, there is no real solutions. But if it says solve, solve it. Whether you have a real solution or a complex solution, they're all solutions, because they didn't say what type of solutions you need to provide. So my solutions are 7i, -7i. All right, so here I feel like we're gonna have another complex solution here, but let's go ahead and solve it. We have 6x minus 7 squared. We take the square root of it, equals plus or minus the square root of -25. Use the same I property here and separate this as 6x minus 7 equals plus or minus 5i, right? And then now we can go ahead and separate as 6x minus 7 equals 5i, or 6x minus 7 equals -5i. Okay, so now that I have two equations, I can solve each and see my solutions. Plus 7 for each side, because I want to isolate the variable here. And that gives me 6x equals 7 plus 5i. And then 6x equals 7 minus 5i for the second equation. Divide by 6 to get x equals 7 plus 5i over 6. And x equals 7 minus 5i over 6. So these are the two solutions of my equation. So then I can present my solution set. My solution set is the two values, x equals 7 plus 5i over 7 plus 5i over 6, and 7 minus 5i, 7 minus 5i over 6. And then next problem here, to solve by quadratic, by the radical property or the square root property will be here, that we need to move this over, just like we did in this case. Move the constant over, subtract 50 on both sides, cancel this, that's x plus 2 squared, that we can take the square root here to simplify the square, and then plus minus the square root of negative 50. And then the new equation become x plus 2 equals plus minus. So that we have the negative sign inside of the radical, there will be I somewhere on the outside to get rid of the, because there will be, this will be square root plus or minus square root of negative 1 times square root of 50. And 50 is 2 times 25 times 2. So square root of 25 is 5, and then square root of 2 is a decimal, so I'm going to leave it as a square root of 2. So square root of 25 is 5. So I have this. So 5i square root of 2 is this. And then two solutions possible. The first one, x plus 2 equals 5i square root of 2. And the second one is x plus 2 equals negative 5i square root of 2. Now we can subtract 2 on both sides to isolate x. And then we got the two solutions. X equals 5i square root of 2. Oh, let me put the negative 2 first. So negative 2 plus 5i square root of 2. And the second solution is x equals negative 2 minus 5 square root 5i square root of 2. And my solution set, first one, negative 2 plus 5i square root of 2. And the second one, negative 2 minus 5i square root of 2 minus 5i square root of 2. So I have my solution set. So we did the review, the last problem in the review, that is about solving quadratic equations by the square root property. So again, solving quadratic equation by square root property means that you want to have something squared plus a constant or minus a constant equals 0, or it can be anything, but the problem will have a square and a constant. Then the constant, if it's not already on the other side, you need to isolate the square, squared expression, and then take the square root of both sides. Remember to have a plus and minus on one side, because it's going to give you two solutions, one with the positive value, one with the negative value of the square root of the constant, and then solve for x to find the equation, one with equation with the positive, one equation with the negative value of the square root of the constant. Now these equations, the new ones that we're gonna have, are still quadratic equations, but they want me to solve them using the quadratic formula. And quadratic formula is something that you need to know by heart when you're coming to your test, because You're not going to be allowed to bring anything just like everybody else. You need to remember it. And the more you do problems, the more you will remember the formula. So this formula says, if I have a quadratic equation in this form, ax squared plus bx plus c equals 0, it can be solved using the quadratic formula that is x equals negative b, the value, the x coefficient of x, plus or minus the square root of b squared, the same coefficient of x that you square, minus 4, this 4 is in the formula, a, the value of a, coefficient of x squared, not x squared included, just the coefficient of x squared. And if it's nothing, that means it's 1. A and c. C is the constant term. Divided by 2a, 2 times the value of a. Now that you know this, we can use it by, first we want to start identifying a, b, and c in this formula, in this equation. So 0 on one side and the expression in standard form on the other side. Everything is fine. Then I can go ahead and isolate, find a equals 1, b equals -7, and c equals 3. And then I can go ahead and set up my equation, my formula, so I can put it. The way I like to do it is I set it up first, and then inside of these parentheses, I'm going to put the values corresponding to what they are. So I know that I need to square something that will be the b value, plus or minus 4 times one value that is the a value, and then times another value that's going to be the constant. And then on the denominator, I multiply 2 in the value of a. And then after I do that, I'm sure, because when you don't do that, you risk yourself, if there is a negative sign, to not really do well. But I mean, it's okay if you don't do it this way. You sure about yourself and you know what you're doing, that's better. But for those who are not sure, please take your time and do what you got to do, because all you want is to do well and then pass your test. Okay? And then it'll tell something about you, the precaution that you take, and then moving forward, you know, what you don't know, and the precaution that you need to take. Okay? So that said, let me plug in the b value, -7, the a value now, 1, and the c value once only. So a and b, you put them twice in the formula, but c is only once. And then now we can simplify this. X equals, I like to do the work inside of the radical first and keep the simplify if necessary. So that is -7 is +7, plus or minus the square root of 7, -7 is 49. 49 times 49 times, no, not 49 times. So let me put it down. Square root of 49 plus, no, the inside is not plus or minus, I'm sorry. It's just minus, sorry. Plus or minus is only on the outside, just like I did in the formula here. So 4 times 12, 49 minus 12 over 2. And then the two solutions are, after simplification, the two solutions are 7 plus minus the square root of 37 over 2. And then these are your solutions. Let me give the solution set here. Plus 7 plus minus the square root of 37 over 2. So you see, you can give it as plus or minus, or you can just separate them. I think I'm dealing with a room problem here, so that's why I just give it this way. Next, in this problem here, I'm seeing something that is not zero. This is not zero on this side, and then I want to zero my equation out in this case. Whenever you're solving by quadratic formula, you always want to put the equation, everything on one side in standard form, and then 0 on the other side. So that's why I want to subtract 5 on both sides. So 4x squared minus 2x, not x, right? So that is m, minus 2m minus 5 equals 0. Your quadratic formula, you know it, x equals, I'm just going to plug in the values because we want to go fast. For the once you understand it, we can go faster. So that is negative 2, that's positive 2, plus or minus the square root of negative 2 squared minus 4. A is 4, C is negative 5 over 2 times 4. And then now we can simplify the value, the operations inside of the radical to get x equals 2 on the outside plus or minus the square root of 4 plus 16 times 5. I put a plus because I have a negative sign and another one to multiply. I know the result will come out positive, and then we multiply them. It's 84. 84. And then now every time you have an expression inside of the radical, you want to see if you can simplify it. Well, that 80, that's 80, but when you add the 4, it's 84. So that's one thing that is going to be just 84. And then 84, we want to solve the square root. We want to solve the square root. So let me break it down. 2 times what equals 84? 2 times what equals 84? 2 times 42, right? Break it down again. 2 times 21. And then we're solving a square root, so 1, 2 out. So we're not forgetting that's 8 on the denominator. So next, you got x equals 2 plus minus 2 square root of 21, right? Over 8. Simplified by 2, we got x equals 1 plus minus square root of 21 over 8 over 4. And then solution set is, your solution set is 1 plus square root of 21 over 4, comma, 1 minus square root of 21 over 4. Remember, I told you that you could give it as 2 separate solutions, or the plus or minus, both of them work. Next problem here. X equals, A, we can just apply the formula. A equals 1, B equals 2, and C equals 26. x equals negative b, negative 2, plus minus the square root of b squared, so that's 4, plus or minus actually minus 4 times a 1 times c 26 over 2 times a 2 times 1 is 2. And then we got x equals we want to simplify that. Negative 2 plus or minus square root of, once we simplify, the answer is negative 100 over 2. And then we know whenever you have a negative number inside of the square root, then it's going to be you referring to your I property. Square root of negative 1 equals I. So, and then we know that square root of 100 is 10. So that is negative 2 plus or minus 10i over 2. Divide by 2. So your solution is negative 1 plus or minus 5i. And then this, we should multiply to cancel the denominators. Multiply by 7. And then once you multiply by 7, your new equation is x squared plus 7x equals negative 5. Then add 5 on both sides to zero your equation out. And then get x squared plus 7x plus 5 equals 0. Plug into your quadratic formula, minus 7 plus minus the square root of 7 squared minus 2 times 1 times 5, 4ac, I mean 4, not 2, 4. 4ac over 2 times 1. Then we're going to simplify to get, we want to simplify this to get negative 7 plus minus, negative 7 plus or minus square root of 7 squared is 49 minus 20, so that's 27. 29. Square root of 29 over 2. 29 is not a perfect square and does not have a perfect square factor that includes in it. So my solution is negative 7 plus or minus 29 divided by 2. All right. And then our final problem for this review will be this equation where A equals 3, B equals 1, and C equals 6. X, our formula, quadratic formula is x equals negative b, negative 1, plus or minus the square root of b squared, 1 squared is 1, minus 4, a, 3, c, 6 over 2 times 3. So x equals negative 1 plus minus the square root of 1 minus 4 times 4 times 3 is 12. 12 times 6. 12 times 6 is 6 times 10, 60. 60 times 6 times 2 is 12. Okay, 12 times 6. And use my calculator real quick to make sure and be quick. 6 times 12. 72. 72 minus 1 is negative 71. Let me do one more step. Over 6 and then 71. So x equals negative 1 plus minus square root of negative 71. And 71 is no way to be broken down into any factors except for 1 and 71. You know what this is. Prime number. Yes, for those of you already said it. And then now your solution x equals negative 1 plus or minus I square root of 71 over 6 is our solution. So this one I'm going to split it. Negative 1 plus I square root of 71 over 6. And the second one is negative 1 minus I square root of 71 over 6. So that is the review for test 3. Everyone will have 100 if you watch the video, I promise. And remember and learn from it. It's not just you watch and not taking note. And then remember at the end, after you watch a video, you can go ahead and do your practice test on MyLab Math for 10-point extra credit out of 100. Go, and good luck, everyone. That was it for part 2, test 3, practice problem.